Hi folks, Mr. Long here. We're going to do a screencast, or rather I'm going to do a screencast on how to find the points of intersection between a parabola and a line. So here's the parabola right here, -2 bracket x plus 3 n bracket squared plus 17, and the straight line y equals 2x plus 5. Well, the first thing we would always do is to make a rough sketch. So let's look at the parabola. What do we know about this parabola? Well, what's the vertex? Well, the vertex, if I want to make this square worth 0, the variable square, make it 0, then x has to be -3. If this is -3 here, then this whole thing is 0 and 17 is left over for y. So it looks like the vertex is at -3 and all the way up here to 17. Okay, so that's ballpark what it looks like. Then, so that's right there, that's -3 and 17. Then we have to be concerned about the straight line. Well, what's the y-intercept of the straight line? It's +5. And the slope is +2. So I put a mark here, maybe about 5, and it's sloping up. Again, it's just ballpark. Okay, so we know that there's going to be one x-intercept near the y-axis, and then there's going to be another x-intercept, or another intersection point rather, down here. Okay, farther to the left. All right, so here's our process page. So this is line by line, and what I'm going to do is refer to each line as I go through the process. So the equation right up here of the parabola and the equation of the line. So let's look at this. How do we solve this? Well, what occurs at the point of intersection? At the point of intersection, the y values in the parabola or the line are the same. When we subtract two things that are the same, this is in line 1, we'll always get an answer of 0. Okay, so the y value of the parabola minus the y value of the line must be 0. Line 2. So in line 2, I replace y value of the parabola with the equation of the parabola. And then I subtract off the line. Subtract, and then I put it in brackets. Always put that line in brackets. And that difference between those two is 0. Okay, when they're at the point of intersection, that's line 2. What happens between line 2 and line 3? Well, line 2 and line 3, I need to expand this perfect square, right? Expand that perfect square. So I need to do x squared, then it's 2 times 3 times x. 2 times 3 is 6, times x is 6x. That's the middle term. Then I've got 3 squared here, okay? 3 squared, which is 9, okay? Then after that, I've got to multiply this -2. Sorry, I'm stepping ahead to the next line. So that's line 3 is just the focus on the expanding there. So when we go to the next line, line 4, I need to expand this -2 through the brackets. Okay, so according to BEDMAS, I had to do the exponent first, then I multiply. So -2 times x squared, -2 times by 6x, -2 times by 9. And we get this -2x squared minus 12x minus 18. Then I still have the plus 17. Then I've got minus this 2x, that's minus 2x. Then I've got a minus a +5, that's minus 5. Now I need to, that's line 4. Line 5, what I've done is collected all the like terms. Okay, I put like terms together. So I take this -2x and I move it over here beside the -12x. So -12x minus 2x, that can be combined. Then I've got, so that can be combined there. And then this, all of this can be combined right here, right? So the -5 minus 18 plus 17. So -14x in line, that's line 5. And in line 6, I simplify. -2x squared minus 14x's minus 12x minus 2x, and then -5 minus 18 minus 23 plus 17 is -6. Notice here, so that's line 6. So I could go ahead and use the quadratic formula with this, -2x squared minus 14x minus 6. But I don't want to work with 3 different negatives. So here's what I'm going to do. I'm going to multiply both sides by -1. Okay, I'm allowed to do that. So if I multiply this side here by -1, it's 0 times -1 is 0. then I'm multiplying this line up here. My apologies. So negative 2 times negative 1 is positive 2. Negative 14 times negative 1 is positive 14. Negative 6 times negative 1 is positive 6. 0 times by negative 1 is 0. So why did I do that? Because I don't want to work with negatives if I don't have to, right? I multiply both sides by negative 1, and now I have this equation right here. Now what we're going to do is come across all the way over here and work through the process now. Now we're on line 8, but it's several lines in line 8. So now we're going to do the quadratic formula. First thing is to do the discriminant, b squared minus 4ac. There's the a, b, and c value. I substitute those into the discriminant and evaluate. Evaluate means put things in your calculator. Remember that take this equation right here and just put it directly in your calculator. And if you do that, you're going to get a discriminant value of 148. After that, I'm going to get Z1, the first intersection point, okay? I call that Z1. So there's our formula, negative b over 2a minus the square root of d over 2a. And that's section 9 or line 9. So what I do after that is I just substitute in negative of 14, 2 times 2, 2a, minus square root of d there, all over 2a. Put that on my calculator and simplify. I get negative 3.5 minus 3.041. If I simplify that, I get negative 6.541. Now, that's the furthest to the left of the intercepts, okay, intersection points. That's the x value. Z refers to an x value. So now, how would I get the other one? How would I get the other one? Well, it's going to be negative 3.5 plus 3.041. So you would just put that directly in your calculator. Negative 3.5 plus 3.041. And now we've got our two x values for intersection points. Finally, we're going to get the x values. We're going to use the x values that we have to get the y values at the points of intersection. So first thing I want to do, I just want to take a look and see if these x values are reasonable. So negative 6.5. Well, that's negative 6.5. So that's the x value right here. Okay, if we go up to the x-axis. Then the other one is negative 0.459. So if we look, that's somewhere close to the y-axis. So that does make sense. So now what about y values? Well, I'm going to use the equation of the straight line, 2x plus 5, to figure out the y values. So I know that the first point of intersection, the x value is negative 6.5. Now I replace x with negative 6.541. So right here I'm replacing this x, right, with negative 6.541. And then 2 times that plus 5, negative 8.08. Well, what do you notice? So if you look, that's quite a bit. That distance there is 8.08 below the x-axis. That does make sense, because over here, this is, the other y value is 4.08. Okay, so it looks like that's only up 4 units. So this is down 8 units, this is up 4 units. So our ordered pairs of intersection here and here correspond to the original graph that we did. Okay, folks, so here's what I would encourage you to do. Pause, rewind, etc. to go through that again. What I would also do is perhaps even do this one at a later point in time. Now that you've seen it's been gone through, then take a look and try and do it yourself. Okay, so pause, rewind as needed. Make sure you know the process for solving these. Have yourself a great day.